Today, we're going to look at these three rules. Here we go. Try and do the first three. Today, we are doing a summary, so like a recap of quotient, product, and chain rule for derivatives. All right? Okay. Today, I'm going to show you again how to do them. I'm also going to do some examples that involve trig and that E formula, that exponential one. Okay, so the first one, there's two functions and they are being multiplied. So any guesses what rule we use? Product rule. Okay? Don't expand them. So, here is a little summary of all three. Let's have a look at the product rule. The product rule is if you have two functions being multiplied, you want the derivative, so you do the first function multiplied by the second function's derivative, plus the second function multiplied by the first function's derivative. That's the product rule. So you let something equal u, let something equal v, find the derivatives, sub it in, simplify. Those are the 4 steps. So let's do that. First step, u is equal to the first bit, v is equal to the second bit. So if you've done that, give yourself a tick. If you found the derivatives in terms of x, give yourself a tick. Next, we want to sub it into the formula. So in case you forgot the formula already, here it is. The first one times the derivative plus the second one times the other's derivative. So y equals, sub it all in. Give yourself a tick if you subbed it all in. I don't know, what do people think? Is it in its simplest form? I don't know, I'll have a look. I'm not sure if you have to keep going or not. Let's see what it looks like. So using FOIL, you can expand, and then you can simplify. -4 plus 9. Positive 5. What's happening in this question to the function? How do you know? It's not a fraction and it's not a multiply. It's like got a power, so it's like a function within a function. So it's a chain, as they call it. Okay, the chain rule again also has 4 steps. You let the function within the power equal u, find the derivative of that, and then pretty much use this rule and simplify. So I'm letting the function inside equal u. I'm finding the derivative. All right, and now I'm finding dy dx. By finding dy du and multiplying it by du dx. So if y equals u to the 4, dy du equals 4u to the 3. Do you remember this? Yes. Bring the power out the front, -1 from the power. Yeah? So now I have dy du, I have du dx, I just multiply them. So dy du multiplied by du dx. And the last step, which people often forget, once we have that answer, what do we need to do after that?
Replace a u with the old value.
With the original x function. Yep, very good. That's the most common error. So please write it down. Okay, so last one. Hopefully you got all of that right. We have a function over a function and a fraction. What's happening? They are being quotiting. They are being divided. So we use the quotient rule, another word for divide. So you let the top function equal u, the bottom function equal v. That's the first step. You find the derivative in terms of x of each of those. So bring the power out the front, -1 from the power. Okay, and then use the really complicated quotient rule. That was the first step, that was the second step, now we're subbing into this. Okay, so I've subbed into the function. Ta-da, that's the massive derivative of that. Go at this question. First rule. What was the first rule? Let u and v equal something. What's the u? What's the v? Find the derivatives. Negative sine x. Use the rule. U v dash minus v u dash x times negative sine. Oh, that's meant to be a plus. And then it's cos times 1. So dy dx is negative. So the first step, same as the last one. Oh, no, it's not actually. Ignore me. There's no v this time. So the derivative of u, we did it last question, is negative sine x. That's just the general rule for cos x derivative. We now have y equal u squared. So dy du is 2u. So I found u, found the derivative of u, subbed u in, found the derivative in terms of u, and now I'm finding the derivative in terms of x. So you sub into the rule, negative sine x times 2u. Okay? So it's like the derivative of the function inside, which is cos x, multiplied by the derivative of the whole function, cos squared, or u squared. Nope. Last one, and then you can have a go. All by yourself. The training wheels are coming off. Alright, the first step, same as the product rule. Did everyone get this? Should have got the first step, hopefully. Second step is, after you've let u and v equal something? Perfect. In terms of x. We know that the derivative of e to the x is e to the x. That's the general rule. We know the derivative of sine is cos x. Alright, so the derivative of y in terms of x is the function v times the derivative of u minus the function u times the derivative of v divided by v squared. If you are bored and you want the proof of that, go online. There's heaps of people that have done it before.
I mean that board, just showing how that's the case.
Alright, do you think we need to simplify or factorize?
No, because we don't need to.
This one hopefully is a fairly obvious factorization.
Oh, and then we can do some more stuff here.
Okay, so I factorize the top row, in case you're wondering. So there you go. Two examples of chain, quotient, and product.